Section 4.1, exponents. Alright, in this section we're going to learn the rules of exponents, how to multiply them, divide them, take them to a power, etc. Okay, what is an exponent? Alright, an exponent is that little number that we write up above a variable or maybe another number, a superscript, and this is what it means. In fact, actually, let's label. So in this example here, the exponent is 2. So my exponent is 2. All right, and then we call this x, or whatever is being raised to a power. This is called the base of the power. So we call this whole thing a power, but 2 is the exponent. And what this literally means is x times x 2 times. So if we had something like x to the 4th, that would literally mean x times x times x times x. Okay, so that's what an exponent means. Okay, let's move on to the next slide here. Okay, we should note real quick, before we get too much further, note the following. If we have x, that's actually x to the 1, we just don't write the 1. Okay, so if we have x, that's x to the 1, we just don't write the 1. Alright, okay, so I'm going to erase that, and then let's go to the product rule for exponents. The product rule for exponents says this: if I have x to the n times x to the m, and I'm multiplying them, then this changes to x to the n plus m. Alright, and that only works if we've got the same base. Notice both of our bases are x. If the bases were different, then we would not be able to do that. If we had y to some power and x to some power, we wouldn't be able to multiply them. So let's look at some examples real quick. Suppose I had 3 squared times 3 cubed. Okay. Well, my base is 3, so I don't touch the base at all, right? The base is going to stay the same here, okay? But I am going to add the exponent, so this is actually 3 to the 5th power, and we can see that a little more clearly. Maybe if we wrote this as 3 squared is actually 3 times 3, right? So that's 3 squared, and then we're multiplying that by 3 times 3 times 3, which is 3 cubed. And how many 3's do we have then? I've got 5 3's. That must be 3 to the 5th power. Okay? Alright, let's do another example. Suppose I had, I'm going to erase here again. Suppose that I had something with variables in it, like the one in the example in the rule. So let's suppose I had something like y to the 4th times y to the 7th. Well, add the exponents because I'm multiplying. I've got the same base, so that's going to be y to the 11th. And that's the power rule. Okay? And that's it. So make sure, though, the most important thing is you need the same base. Okay? Alright, cool. Let's go on to the next one. The quotient rule is very similar. It says this: if I have something like x, oops, oh no, go back. Quotient rule says this: if I have something like x to the n divided by x to the m, well, first of all, we're usually going to write this as x to the n divided by x to the m, like that, as a fraction. It's typically how you'll see it. This actually equals x to the n minus m, so n minus m. Okay, So that's my rule. Let's do an example. For instance, if I had something like x to the 12th over x to the 5th, I would subtract the exponent. So this would be x to the 12 minus 5, which equals x to the 7th. So that's x to the 7th. And that's the quotient rule. Okay, so I erased everything. I want to change it up on you. Now before, we did something where the exponent was on top was higher than the one on the bottom. Well, now I want to show you how we can still do this problem when the exponent on top is lower than on the bottom. So I want you to notice this, x to the 5th on top. I'm going to leave that alone, but I could break up this x to the 12th into x to the 5th times x to the 7th. And since I've got an x to the 5th over an x to the 5th, that's actually the same as 1 over 1. Okay, so I can actually rewrite this as 1 over x to the 7th. Okay, so I can still handle situations like that. We will look at that a lot more in 3.2, however. Okay. Okay, I want you to take a look at this example real quick. If I have x cubed over x cubed equals, then I know by my rule that that's x to the 3 minus 3, which is x to the 0. X to the 0 is actually 1, and here's why. If I rewrite x cubed as x times x times x divided by x times x times x, this is actually going to be, well, these x's go away. And I realize I just put x's through x's, but that's 1 over 1. These x's go away here. That's 1 over 1. These x's go away here. That's 1 over 1. Well, I think all we have here then is 1 over 1, which is just 1. So anything to the 0 power is just 1. Okay, let's look at the power rule now. The power rule says this, and before we even give you the rule, I want you to look at an example. When I talk about power rule, it's really power to a power rule. I could rewrite this x cubed to the second power as x cubed times x cubed. That's the definition of squared, right, or to the second power. And now I'm just multiplying two powers, and that means I add the exponents. So this would actually be x to the 6th power. Well, you might have noticed that that's actually x to the 3 times 2 power is x to the 6th power also. And that leads us into the power rule, which says x to the n. If we raise that to the m, then that is actually x to the n times m. Let's suppose we had an example like this and we wanted to simplify it. This one is a little bit different because if you notice, I've actually got two bases. I've got this, whoa, watch out. I've got this base here, 4, and then I've got this base here, y. So our power to a power rule works a little bit different. Note real quick that this is 4y squared times 4y squared times 4y squared 3 times. And if we rearrange these numbers, this is actually 4 times 4 times 4 times y squared times y squared times y squared. Okay, and that is actually 4 cubed and y squared cubed. Okay, so, and this simplifies to 4 cubed y to the 6th. So my point here is that I think we can go from new color. I think we can go from here to here pretty quickly, and I'll show you how. This thing could be rewritten as, in fact, let's just do it again. 4y squared to the 6th is actually, cubed is actually 3 cubed to the y times y to the 6th, because it's a little bit like the distributive property in that I have to take this cubed and apply it to the 4 and apply it to the squared. Okay, so that means that I probably should have written this as a 4, not a 3. But anyway, should have written it at, I got to make sure that that power to a power goes to every factor. in the base. Okay, let's do another one of those. I'm going to clear the board here. Let's do a squared b cubed to the fourth. This is actually going to be a squared to the fourth. And I didn't need both sets of parentheses there, but also then it's going to be b cubed to the fourth. And power rule says that this is actually a to the 4 times 2, which is 8, and b to the 4 times 3, b to the 4 times 3, which is b to the 12th. And that's it. So make sure you distribute the power to both factors in the term, okay? Suppose I had this 5 over x cubed, that quantity squared. That leads us to our next rule, power of a quotient. And I think that we could rewrite this as 5 over x cubed times 5 over x cubed, which I think is the same as 5 squared over x cubed, that quantity squared. And then we could simplify from there. This is actually 25 over x to the 6th. Okay, but that leads us into our quotient rule, which says this: if I have x to the n divided by, if I have x over y raised to the n, I'll write that over here, raised to the n, then this is actually x to the n divided by y to the n. Okay, so that power applies to both the numerator and the denominator. Okay, let's do another example. Okay, here I want to take and I'm going to apply the square to both the numerator and the denominator. So this is actually 2r to the 7th s raised to the 2nd power divided by t to the 4th raised to the 2nd power. Okay, this is actually then going to be 2 squared times, in fact, you know what, I'm going to just expand this real quick. 2 squared is 4. R to the 7th squared, so that's 7 and 2 is what I'm looking at. R to the 7th squared is going to be r to the 14th, power to a power rule, and then s squared, divided by t to the 4th to the 2nd is t to the 8th. And we double check, can I get any simpler than that? It doesn't look like it. So that's as simple as I can get for that example. Sometimes we'll want to simplify inside the parentheses first before we can, do the power of a quotient. So let's simplify inside the parentheses first. It looks like I've got a y squared over a y. Well, let's be careful here. Let's start with 9 divided by 3. 9 over 3 is 3, so I've got a 3 in the numerator. Okay, and then x cubed. X cubed and an x to the 1, but we don't really write it. That's going to be an x squared, right? 3 minus 1. And then I've got this y squared. That's going to go to a 1 divided by y squared. Y squared over y squared is just 1, so that's times 1. And do I have anything left on the denominator? I don't think so. I think I've just got 3x squared, over 1. I think I've just got 3x squared cubed. Okay, well, let's rewrite that. 3x squared, that whole thing, cubed. That's going to be 3 cubed times x squared, quantity cubed, which is just 27 times x to the 6th. 7 times x to the 6th. Okay. Okay, this is one that should be, it's a little bit more complex. The expanded power rule. Basically, the idea here is that, I don't even have an actual rule, so I guess we'll just get rid of that. But the idea here is that I simplify this thing on the left here first, and then kind of multiply it by the thing on the right. Okay, so these are being multiplied together. And so that, like I said, that's the idea on this one. So I'm going to simplify the thing on the left first. That's going to be 2 to the 5th times a to the 5 times 5 is 25 times b to the 5 times 3 is 15 all times 3 times a squared times b. Now, I've got, let me rearrange the terms so some of the terms are next to each other. I've got 2 to the 5th, right? 2 to the 5th times 3 times a to the 25th times a squared times b to the 15th times b. And now I think I can finish this up. 2 to the 5th is not going to change. 3 is not going to change. But a to the 25th times a to the 2 is a to the 27th. And b to the 15th times b to the 1 is b to the 16th. Okay, and that's it for that one. Okay, I can't get much simpler than that. We could have multiplied this 2 to the 5th out times 3, but we didn't need to. And that should get you rolling on exponents, at least for a little while. I apologize for the length of the video, but there's a lot of stuff packed in that section. So we will see you in class.